So now we'll discuss and understand the EIGRP authentication. So authentication means that if you are sending update from one router to the other router, then you should supply some passwords or some username, some authentication parameters. Otherwise, let's say I've configured an EIGRP, I'm the valuable customer, I'm the authentic customer, and some attacker is there. So he may also join his router. Say he has configured EIGRP and he may join his router, and also you will also receive update from my authenticated router. That should not be the case. So we'll explore the enhanced integrated routing protocol and its authentication. First, we'll explore some features of the EIGRP related to the authentication, and then we'll configure the authentication. So you already know EIGRP is a very vital protocol for routing within a large network, and it provides the rapid convergence and efficient management. So you have to understand this authentication means if you're just configuring the EIGRP and not doing any authentication, then what will happen? The security will not be there. So in any production environment, you cannot just configure the EIGRP and let attackers attack your network. That shouldn't be the case. So you have to implement the authentication. So you have to understand this authentication mechanism, and it's essential to ensure secure and reliable network communication. So what is EIGRP? EIGRP, that is Enhanced Interior Gateway Routing Protocol, as you know, is a dynamic routing protocol developed by Cisco. Obviously, and it's a hybrid routing protocol or an advanced distance vector routing protocol because it has many features like of link state and of distance vector. So it effectively integrates features from both link state and distance vector routing protocol, and it is a very advanced routing protocol, you can say, because it is fast. Its rapid convergence and efficient use of bandwidth is very crucial in the network. Now, what are the importance of EIGRP? First of all, it ensures data integrity. EIGRP authentication verifies the source of the routing updates, ensures that only legitimate routers can exchange routing information. This is a very important point. The illegitimate routers or the attacker routers should not be given any chance of exchanging the routing updates because EIGRP exchanges the routing updates with the hello packets at the multicast address of 224.0.0.10, as we know. So if any attacker is involved in the process, then definitely the entire network will be sabotaged. So I do not want to do that. So this verification process helps maintain data integrity within the network and preventing incorrect routing entries. Even it may configure, say, suboptimal routing or loop. So if I'm the attacker and I am just planning to have some, say, some routers, and I have deployed it and I am sending update from that router. So definitely anything can happen. Even it can create routing loop. The authentication prevents unauthorized access. Unauthorized access to routing information can lead to significant network vulnerability. So EIGRP authentication effectively prevents this by allowing only authenticated devices to participate in the routing process. So thereby protecting network nodes from malicious entities. So definitely EIGRP authentication doesn't allow routing updates to send or being received by any entity without any password, or we have MD5 authentication there in the EIGRP, not only clear text but the MD5 authentication. So if you are not using the authentication, then definitely nobody can access the routing address. Enhances network security. By implementing EIGRP authentication, networks are better equipped to defend against routing attacks such as spoofing, replay attacks. Spoofing is a very dangerous attack where you spoof the MAC address of the devices. You supply the same MAC address that is already configured in the device's NIC card, and you spoof the MAC address. So you can actually redirect the request to your PC. So if I'm the attacker, I can spoof your MAC address, and also there's an IP spoofing attack or MAC spoofing attack. So this replay and MAC spoofing attacks are very dangerous in the network. So this enhancement of security is essential for maintaining a robust environment. And here in EIGRP, how to implement the security, you have three things. One is the key chain. Key chain is the chain where you have the key. Then you have the key and the key number. And last is the key string. Key string is a very important part. So if you're having the keychain, if you're having the key number, then if the key string is not matching, if both are matching, the keychain and the key value is matching, but the key string is not matching. So on one router it is CC and another router is ABC. So for example, definitely your authentication will be failed. So types of EIGRP authentication that I was telling you, one is a simple password authentication, that is a clear text one. Now this is vulnerable. Anybody could hack into it, anybody could break into the password. And then the MD5 authentication security, that is MD5, as we know, that it already changes. If you are giving one password, then at the next time it changes. So it is a MD5 authentication security is very secure. Then how to configure the EIGRP authentication? First of all, enable the EIGRP. We activate the EIGRP on the router. Initiate the routing protocol, because if you activate the routing protocol, then it joins the multicast group and it sends the periodic update. Number two, configure authentication method. You can set up either simple password, that is a clear text password, or MD5 authentication to secure routing update. Step three is apply authentication to EIGRP process. So integrate the chosen authentication method into the EIGRP configuration to enforce security. So you have to actually implement the authentication. The step one, enable EIGRP. Step two, configure authentication method or MD5 authentication. Step three is apply authentication to EIGRP process or enforcing security. So these are the very three steps or three important points for EIGRP authentication, and we'll configure the EIGRP authentication and with the MD5. So that is about the EIGRP authentication theory part, and now we will go straight to the GNC console for configuration. So this is my JSL console, as you can see, and there are two routers. You can take even more than two routers, but here are one and R2. These two routers directly connected. So power on those. And now I will provide IP address. I will configure the EIGRP, and then I'll configure the authentication. So the routers are starting. Check with show IP interface brief. There is no such IP address configured. So go to config mode. This IP address is 192.80.1. And I'll configure one loopback. Interface loopback 0. This should be say 1001. Exit router EIGRP, so put 10 network, you advertise every network. So 0000, so every network is advertised. Now go to R2. Similar interface F0 by 0. No start. The address should be 192.168, so 0. Interface 0. Configuring, let's say 200. Again router EIGRP 10, network 000. Now there is an authentication, but configure authentication now on router 1, configure keychain, and say keychain is CCNA, key number is 1, and if you give question mark, these are the available key values, very big, 7 key 1, and the key string, say 1, 2, 3, 4. This is a very vital one. And interface F0 by 0, authentication mode, rather IP authentication mode, then EIGRP, autonomous system tech, and if you give question mark, MD5, and IP authentication, keychain EIGRP system 10, and keychain is CCNA. Now we go to router 2, keychain, say the keychain is CCNP, key values value 1, the key string, this is the key string is different 5, 6, 7, 8. Interface F0 by 0, IP authentication, mode EIGRP 10 MD5, and IP authentication, key chain EIGRP slightly 10, and the keychain was CC. So as you can see, it is giving some authentication value message, and just wait for some time. See, this authentication mode changed, and if you give show IP, no EIGRP root is there. If I again go to keychain CCNP 1 and no key string 5, 6, 7, 8, and whatever key string I gave here 1, 2, 3, 4. So key string, again you enter the keychain, key value 1, key string should be 1, 2, 3. And now you see, as I have given the correct key string, the neighborship established on both the routers. So previously the neighborship wasn't established because the key string was different. If you now give show IP root, you should find this EIGRP root or show IP root and write out EIGRP. Yes. And on R2 also, show IP root and find the EIGRP as well as you can filter it out to EIGRP root. So the vital thing is the key string, the key chain or the key value is not so vital. You can change the keychain name. You can use any key value. Here the key value is 1, but here on R2 the key value can be anything. It can be 10 to anything. But the main point is the key string should be same. Key string cannot be 5, 6, 7, 8 because here also then you have to use the same key string. So that is the point, that you have to use the same key string. Like it's 1, 2, 3, 4. Here also you have to use 1, 2, 3, 4. So that is about the EIGRP authentication, the MD5 authentication that I've shown you. So I'll see you in the next video.